Hey physics peeps, we're going to go over series and parallel circuits. And really our goal is to be able to solve for the resistance, the voltage, and the current at different points throughout the circuit. I'll show you what I mean by that here in a little bit. First of all, just kind of a recap of series and parallel circuits. Remember, series circuits are really circuits that have only one path for current to flow through. Parallel circuits have parts that branch off and things that run parallel to each other. And this really causes or allows current to flow through multiple ways, or there's multiple ways of getting from the positive side of the battery to the negative side of the battery. So it can go through this path, or it could go through this path, and it's going through all of them simultaneously. But when we talk about series circuits have current that can only follow that one path. So current is really the same at all points. So if you have 1 amp of current that flows through here, you will have 1 amp of current that flows through every single part. Or in this case, it's 0.25 amps that will flow through every part. The voltage drop adds up to the total voltage of the battery. Remember, voltage is really coming from the battery. Voltage drop is really energy used by different things. But if one part of your circuit uses up 0.25 amps, another part of your circuit uses up 0.5 amps, another part of your circuit uses 0.75 amps, that's awesome. But all of these voltage drops from these different light bulbs or different things in the circuit, they add up to the total voltage of the battery. The total resistance increases as more resistors or more resistance is added to the circuit. Like in this circuit, there are light bulbs and each of them has resistance, like 1 ohm, 2 ohms, 3 ohms. That total resistance is really just adding them up. And so this is true for a series circuit. We say the total resistance is just R1 plus R2 plus R3 plus any other ones that we have in there. Okay. So here we go. We're going to just kind of go over this type of circuit and be able to fill out tables. I'll show you how to solve these out. And so starting off with series circuits. We have a circuit like this here, but what we need to do is figure out the resistance, the current, and the voltage at all points in the circuit. That means at this point where there's a component like a light bulb, at this point where there's another light bulb, and at this point where there's a battery. I'll show you kind of how to fill that out, but first you need to copy this down on your paper. Go ahead and pause the video. I want you to copy this down where you have RIV. You have 2 rows, and then this last row has total written on it, or you could write total over here on the side. Go ahead and do that. Pause now. All right, that's cool, you guys. So here's the thing. R stands for resistance, I stands for current, and V stands for voltage. But when we fill this out, we're really putting information in here that's about the circuit. And there's some things in here that we can put in, like our resistance. We're going to put each resistor into this table. Like this resistor is 1 ohm. This resistor is also 1 ohm. And then this 6 volts, this is the total voltage for the circuit. So under this column for voltage and in the total column, I'm going to write out 6. And that is my voltage. Now there's all these other parts that we have to fill out because through this light bulb, it has resistance to it, but it also has a current that flows through and it will have a voltage drop. And same thing for this resistor. But how do we figure all this stuff out? Well, it's kind of like a puzzle. You have to start off by listing things that you know. That's step 1. That's kind of like what we did. Second step is to start putting things together that you can find out. So it's like I have my resistance here after I have, but I can figure out my total resistance because I have these two things in the column. My total resistance, because this is a series circuit, my total resistance is equal to R1 plus R2 plus R3 plus blah, 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 blah. I really only have two resistors, so I'm just adding these up. It's 1 plus 1. And so I get a total of 2 ohms for my resistance. And so I got that part. But then it's like all these other parts. How do I figure these things out? Because the current, I don't know the current. It doesn't tell me on here. And the voltages, like what does this mean? We'll get into that. But your total current and really kind of anything that's in here, if you have two things that are in a row, you can relate those two things to figure out the third thing in that row. And it really comes from the relationship that we've used before, and that's Ohm's law. This I equals V over R. Because I know the total resistance and the total voltage, I can solve for the total current. Just keep in mind, it has to be done in the same row. You can't use like this 1 and this 6 and try to figure out this one right here, because you don't have everything in this row. You need to have it in the same row. And so I'm going to solve that out right here and use that equation I equals V over R. I'm going to solve for I. That's what I want to solve for. That's what this column is. But the voltage is 6 volts in this row. The resistance, the total resistance is 2 ohms. If I divide those, I get 3 amps for my current. And I'll put in units. Maybe that might help kind of clarify some things too. So here's what we got. Now, when we actually have this, there's a trick. This is a series circuit, and there's something that stays the same in a series circuit, and that's the current. The current that flows through this light bulb is the same as the current that flows through this light bulb and comes back to the battery. So in a series circuit, it's current that stays the same. Sometimes people find it helpful to write same above I because for a series circuit, because then it's kind of a clue to them. Oh yeah, if you know that this is 3 amps, and when we say the total current is 3 amps, that is the current flowing out of the battery. That's also going to be the same current flowing through each one of these light bulbs. And so we can just put 3 amps in for everything in that column. Nice. But now I need to solve out for the voltage in that circuit. Okay? So the voltage, again, it's kind of like, well, what actually goes in here? Because I know two things in each of these rows, I can use that equation I equals V over R and solve for the voltage. I'm going to put things in where they belong though. The current, it is 3 amps. So that goes in place of I. I'm going to solve for the voltage, and the resistance for this one is 1 ohm. To solve for voltage, I have to multiply 3 times 1. I get 3 volts. And this is the voltage drop across this light bulb. For the second one, I'm going to do the same thing. It's 3 equals V divided by the resistance. And the current was 3, resistance is 1. I solve for the voltage, I also get 3 volts. And this is kind of how I solve it out. Now this should actually work really well, and I'll show you kind of in the next one how you can end up checking your answer. But that's how we go about doing these tables, where you use resistance, current, and voltage. You fill out what you know from the circuit. Most cases it's like the resistance and the total voltage. you can solve for that total resistance. You can then use I equals V over R to solve for the current. That stays the same throughout, and then the voltages you can solve for using I equals V over R. Let's do a different one here, and then we should be good. Let's do, let's do this one. Okay. So we have in this circuit, let's do this circuit. Okay. So we have our resistors. We're going to list out the things that we know in this problem. First of all, you need to copy down this table. RIV, 2 rows, and then a total row. And then we're going to list out things that we know. We know the resistance for each of these. We have 12 ohms. We have 6 ohms. And our total voltage comes from our battery. It's 6 volts. This is always from your battery. Then I solve out for things that I know. It's kind of like a puzzle. If I can solve for things in a column, awesome. Like I can figure out my total resistance. Remember, for a series circuit, you really are just adding them up. So if I take 12 plus 6, I get 18 ohms. Then I look at for something else that I can solve for. I don't have 2 things in this row, so I can't solve out for anything. I don't have 2 things in this row, so I can't solve out for anything. But I do have 2 things in this row, so I can solve out for the third thing here. And that's using that I equals V over R. So I put things in where they belong, but it has to come from that row. So the total voltage is 6 volts. The total resistance is 18 ohms. And I divide that, and I'll end up with a decimal, and that's all right. I end up with 1/3 or 0.33, and then I'm going to, so this is kind of what I get. I'm just going to use 2 or 3 decimals. That's fine. But now it's like, well, I can't solve out for these things quite yet, but because it's a series, I know that current is the same. So if this is 0.33, everything's 0.33 amps. And now, because I know these two, I can solve out for the voltage. I can use that equation I equals V over R and put things in where they belong. I know the current is 0.33. I'm solving for the voltage, and I know that the resistance is 12 in this row. So I multiply these things together. Now I'm going to kind of use that 0.33 repeating and kind of make sure that I'll kind of show you something here in a little bit. But when I multiply these, I end up with 4 volts. For this row, I do the same thing. I use I equals V over R. I have 0.33. Solve for the voltage, solve for the voltage, but this time my resistance is 6. So when I multiply these together, I end up with 2 volts. And so, couple things, and now my table is complete. Couple things when you solve this out though, when you end up rounding the decimals, your numbers aren't going to come out exactly like 4 and 2. You might end up with like 3.9 something something something, or 3.8 something something, and then like 1.9 something something. But that's okay. That's okay for now. And it happens because you end up cutting off the decimals. So if you want to keep your the long string of decimals in there and then do your multiplying, feel free to do so. But the other thing is that you want to check your answers here. Your answers should make sense, especially in this voltage column. So the total voltage is 6 volts, and the total voltage drop should add up to that 6 volts, and they do. 4 plus 2 equals 6. If you ended up rounding it, it should come out to be really close. You're in the ballpark. But if you're way off, like you're only getting 2 and it should